What if NASA already had a cheaper, proven rocket that could replace its $4 billion SLS, but chose not to use it? Falcon Heavy, SpaceX's commercial powerhouse, has the thrust, the track record, and the price tag that makes the SLS look obsolete. Yet NASA keeps ignoring it. Is this about safety or politics, contracts, and pride? Because if Falcon Heavy can do the job, taxpayers deserve to know why it's being sidelined. Let's dive right in. For years, NASA has poured billions into the Space Launch System, the so-called backbone of America's return to the moon. But there's a secret that many inside the space community quietly whisper. SpaceX's Falcon Heavy could do the same job at 1/10 the cost. Let's be clear, this isn't science fiction. On paper, Falcon Heavy's numbers already challenge NASA's $4 billion per launch monster. While the SLS barely lifts 95 metric tons to low Earth orbit, Falcon Heavy in its expendable form can push over 63 metric tons, enough to send NASA's Orion capsule and service module into orbit, ready for the trip to the moon. And yet, Falcon Heavy sits unused, almost ignored, while the SLS program continues to burn through taxpayer dollars. So why? That's the million-dollar, or rather the multi-billion dollar question. Falcon Heavy has already proven itself, not once but multiple times. It's launched satellites for the U.S. military, interplanetary missions like NASA's Psyche spacecraft, and even carried Tesla's Roadster beyond Earth orbit during its historic maiden flight. It's reliable, it's reusable, and it's affordable. A staggering contrast to the SLS, which costs more than the entire annual budget of some NASA departments. Technically, there's nothing stopping Falcon Heavy from carrying humans, except paperwork and politics. The rocket isn't human-rated, meaning it hasn't been officially certified for crewed flights. But that's a choice, not a flaw. SpaceX simply hasn't needed to, because Falcon 9 and Crew Dragon already handle all of NASA's astronaut missions to the ISS safely. And here's where the real intrigue begins. With minor modifications, a wider fairing, reinforced structure, and integration adapters, Falcon Heavy could easily launch Orion into low Earth orbit. From there, Orion's service module could execute the trans-lunar injection burn itself. The math checks out. The thrust is there. The delta V works. Falcon Heavy can deliver nearly 26 metric tons into geostationary transfer orbit. Energy-wise, that's roughly 80% of the way to the moon. Orion's own engine could supply the rest. It's a tight but viable trajectory, one that could even mimic Apollo's free return path. A safe orbit that loops around the moon and heads back to Earth without entering lunar orbit. That means Falcon Heavy could take astronauts around the moon and back. No SLS required. It wouldn't even need the ICPS stage that SLS currently depends on. Think about it. A fully commercial solution, cheaper, faster, already flying. So if it's possible, what's holding NASA back? NASA's official explanation sounds reasonable. Safety, integration challenges, mission architecture. But many in the aerospace world suspect there's more beneath the surface. Because when you follow the money, things start to look complicated. The SLS program isn't just a rocket, it's a political ecosystem. It funds contractors in multiple states. Boeing builds the core stage, Aerojet Rocketdyne supplies the engines. Lockheed Martin produces Orion, and Northrop Grumman handles the boosters. Thousands of jobs, billions in contracts, and years of lobbying are tied to this single program. Now imagine if NASA suddenly announced, hey, we can actually use Falcon Heavy instead for 90% less. That would instantly make the SLS, the pride of Congress, look redundant. And redundancy is dangerous in Washington. It threatens funding, jobs, and political influence. So instead of pivoting toward a commercial solution, NASA doubled down on SLS. They called it the only vehicle powerful enough to send humans beyond Earth orbit, even though Falcon Heavy's data shows otherwise. Some engineers inside NASA quietly admitted that integrating Orion with Falcon Heavy would require modifications. Sure, but nothing impossible. Just new structural interfaces, a modified launch abort system, and ground infrastructure upgrades at Pat 39A. Doable engineering tasks. Yet the decision was made, stay the course with SLS. Why? Because canceling it would mean admitting that a private company out-engineered the government's flagship rocket. And that's a hard pill to swallow. But the story doesn't end with Falcon Heavy. There's another player waiting in the wings, Crew Dragon. It's already proven its worth in Earth orbit. It's safe, modular, and reusable. So naturally, some at NASA began asking, why not upgrade Dragon for lunar missions instead of clinging to Orion? On paper, it's not crazy. Dragon's internal volume is 9.3 cubic meters, smaller than Orion's 20, but still roomier than Apollo's capsule that carried 3 astronauts to the moon. Add extra shielding, upgrade life support systems, install a deep space navigation array, and Dragon could handle lunar free return missions. The challenges are real: communication beyond GPS range, radiation protection, and re-entry at 11 kilometers per second, nearly double the speed of an ISS return. But again, they're solvable. SpaceX already has experience building radiation-resistant avionics for Starlink satellites and heat shields capable of withstanding Mars entry speeds. Still, NASA stayed silent. Officially, they called it too ambitious. Unofficially, it would undermine years of investment into Orion, another legacy program tied deeply to U.S. aerospace politics. So here we are, in 2025, with SpaceX operating the most powerful, most cost-effective rockets on Earth, while NASA continues to pour billions into systems designed decades ago. This isn't just about rockets. It's about leadership. China is moving fast. Their Chang'e program already tested lunar landers, sample return missions, and is now preparing for crewed lunar operations by 2030. Some insiders believe their timeline might even beat NASA's Artemis 3 if Starship faces delays. NASA knows this. That's why the agency hedged its bets, awarding contracts to both SpaceX and Blue Origin for human landing systems. Starship for Artemis 3 and 4, and Blue Moon for Artemis 5. 2 competing paths to the same goal, just in case one falls behind. But here's the irony. Both of these landers, Starship and Blue Moon, still depend on orbital refueling, a technology that's never been proven at this scale. That's right. The most advanced missions in human spaceflight depend on something that hasn't yet been tested in real-world conditions. Meanwhile, Falcon Heavy is ready today, proven, reliable, capable, yet it's sitting on the sidelines. Blue Origin's lander might debut around 2027. Its hydrogen-oxygen BE-7 engines are still in testing, and the New Glenn rocket hasn't demonstrated reusability yet. Every delay pushes the lunar timeline further out, and every delay gives China more time to catch up. So again, the question looms: why build untested systems when a proven one already exists? Maybe NASA fears losing control. A fully commercial solution means giving up the traditional structure, the political oversight, the distributed contracts, the congressional influence. If Falcon Heavy proved that a private company could deliver lunar missions faster and cheaper, NASA's entire funding model could be questioned. And that's not just about pride, it's survival. The space race isn't just between the US and China anymore. It's between old aerospace and new space, between government-driven bureaucracy and private innovation. SpaceX has shown what happens when you remove layers of red tape. Rockets evolve at startup speed. Falcon 9 became Falcon Heavy. Starship followed. Every failure became a test, every test a stepping stone. NASA, on the other hand, moves like a glacier. Deliberate, cautious, expensive. It's a clash of cultures, one chasing iteration, the other chasing perfection on paper. Here's where things get interesting. If Starship's timeline slips, and that's entirely possible given the complexity of orbital refueling, NASA may quietly revisit Falcon Heavy as a backup. The infrastructure is there, the capability proven, and the cost undeniable. Some NASA engineers have already proposed a hybrid mission concept, using Falcon Heavy to send an uncrewed Orion or logistics payload to lunar orbit, while Starship handles cargo. It's not official policy yet, but the conversation has started, because the moon won't wait. And here's the twist. Blue Origin's Blue Moon lander, though slower to develop, could unexpectedly become the middle ground. Traditional enough for NASA's comfort, but modern enough to compete. Its modular hydrogen system, if it works, could offer long-term surface operations unmatched by Starship's brute force approach. But even Blue Moon relies on refueling tech still in testing. So while everyone's chasing the future, the one rocket that could already go, Falcon Heavy, remains grounded. So let's do the math. Each SLS launch, over $4 billion. Each Falcon Heavy launch, about $150 million, including payload integration. That's 27 times cheaper. In the time it takes NASA to prep one SLS mission, SpaceX could fly multiple Falcon Heavy missions, send hardware, supplies, test modules, even mock lunar missions. Imagine the data, the experience, the acceleration of progress. But instead, NASA clings to tradition. The result? Delays, cost overruns, and a growing risk that the first human footprints on the moon in the 21st century won't be American. And if that happens, if China lands first, it won't just be symbolic. It'll shift global influence in space for decades to come. It's almost poetic. The agency that once dared to land on the moon with slide rules and hand-drawn charts now fears taking a chance on a rocket that already works. Falcon Heavy represents everything NASA once stood for: innovation, boldness, courage. Yet today it's NASA that seems afraid. Afraid to admit that the private sector might have outpaced them. But here's the truth. The world doesn't care who gets the credit. They care who gets there first. And the window of opportunity is closing. Falcon Heavy is ready. The math is done. The capability proven. The question is no longer, can it replace SLS? It's, will NASA ever allow it to? Because if they don't, someone else, maybe SpaceX alone, maybe China, surely will. At the end of the day, this isn't just about rockets. It's about choices. NASA can either keep protecting old systems that drain billions or finally embrace innovation that's already proven itself. Falcon Heavy is ready. It works. It could take us back to the moon faster, cheaper, and smarter if NASA has the courage to use it. So what do you think? Should NASA let Falcon Heavy take the lead or stay loyal to the SLS no matter the cost? Tell us your thoughts in the comments. If you found this analysis valuable, make sure to like this video, subscribe to Future Space, and turn on the notification bell so you never miss our next deep dive into the future of human space exploration. You're watching Space Hub, where knowledge fuels curiosity and curiosity builds the future. See you in the next video.